Assalamualaikum and good day everyone. So today we are going to continue with the next lecture 2 for the second subtopic composite function ataupun nama lain dia fungsi gubahan. Okey. Benda ni ramai siapa-siapa yang dah ambil maths dulu dah pernah belajar lah. Ya, fungsi gubahan. Okay, at the end of the lesson, students should be able to represent a composite function by an arrow diagram. And then find composite function. And then the last one is to find one of the function when the composite and the other function are given. So we are trying to find the one of the function before we composite it. The given is composite and the other function. Okay, what is composite functions? So composite functions are functions that arise as a result of combination of two or more basic functions. It's not an operation between functions like addition, subtraction, multiplication or division, but it's just a combination. We define g of f of x as g f x, meaning that the output values for function f are used as the input values for function g. So f of x is a result when y is defined by function f. So this is actually the y lah. But this y will be the x for g, means that will be the input. Okay, this can be represented by an arrow diagram. So this is the arrow diagram for composite function. So x is the original element in set A, let's say. So if we apply function f, a relation f on x, so we will have a result of fx. And then this fx is also, if we apply a function g on it, so it will be g of f of x. Okay, so the fx will be the input for function g, and then the result will be gfx. So this is what we call as composite. G of f or gf. Note that g of f is not equal to gx multiplied by fx. It's two different things. Gx multiplied by fx is an operation. Okay, but this one is a composite function, not an operation of a functions. Example 1. If fx equal to 3x plus 1 and gx equal to 2 minus x, find as a function of x f of g and g of f. So how do we do the combination or the composite of the function? So first of all, for question A, we need to write down as this f of gx. So this gx will be the input for function f. So what is gx? So we just put gx inside the bracket. So we will have gx equal to 2 minus x. So it will be f of 2 minus x. Usually we write down fx equal to 3x plus 1. But here the one inside this is not x. It's a 2 minus x. So this x here need to be replaced by 2 minus x, means that the x on the right side needs to be replaced by 2 minus x. So f of 2 minus x will be, this is like if f of 2. So what we need to do is we replace the x with 2. So we have 3 multiplied by 2 plus 1. So we need to replace the input here. So for this one, f will be, f of 2 minus x will be 3 multiplied by 2 minus x plus 1. Not x already, but we have to replace the x with 2 minus x. So simplify everything. We have 6 minus 3x plus 1 will be 7 minus 3x. And then for B, So we want to find g of f. So this is a difference from f of g, because g we have an input of fx. So g of fx, so we have to replace the one inside here as fx, not g already. So what is gx? Gx is 2 minus x. But now we have g of fx. So we have to replace inside the bracket fx as 3x plus 1. Okay, so we have g of 3x plus 1. The same thing we do as question A, because it's n g of 3x plus 1. So this x here, we need to replace by 3x plus 1. So the right side also need to be replaced by 3x plus 1. So what do we have here? It will be 2 minus 3x plus 1. So what is the result? So we have 1 minus 3x. Is this 2 the same of f of g and g of f? It's not the same, right? So we can say that f of g is not equal to g of f. It shouldn't be the same, lah. So we have another properties later, that if we found out that f of g and g of f is the same, so we have a certain name for that things. But generally, f of gx is not equal to g of fx. Okay, example 2. The function f and g are defined by fx equal to 1 plus 2x and gx equal to 1 over x minus 1. Find fgx, find gfx. So both are found by composite. So first A. To find f of g means that we have to replace everything inside the bracket as gx. So what is gx? Gx equal to 1 over x minus 1. So it's f of 1 over x minus 1. And then we have to replace the x for f by 1 over x plus minus 1. So it will be 1 plus 2 multiplied by 1 over x minus 1. So simplify everything. What do we have? Find the common denominator. We have this is equal to 1 plus 2 over x minus 1. So this is 1 over 1. So to find the common denominator, we just have to cross multiply. Okay, so at the bottom we have 1 multiplied by x minus 1. And then at the top, on the left side, we have x minus 1. On the right side, 1 multiplied by 2 is what? 2. So what we have here is x plus 1 over x minus 1 for f of gx. Okay, how about g of f? So g of fx, so we replace with fx first, which is 1 plus 2x. And then for g of 1 plus 2x, this function origin of gx, we replace the x here with x on the right side with 1 plus 2x. So it will be 1 over, what is the x? Our x is not x already, but it's 1 plus 2x. That's why we have 1 over 1 plus 2x minus 1. So we have 1 over 2x. So notice that it's not the same. gf and fg is not the same. Example 3. Function f and g are defined as fx equal to 2 minus x and gx equal to 3 over x plus 1. Show that f squared x is equal to x. Find an expression for g squared x. Okay, so what is f squared x? So it's not f multiplied by x 2 times, but the f is composite by f. Okay, so f of f. If a square, it will be f of x all square. So this is square, multiplication between fx. But here is a composite of f with f. Okay, so f of f is equal to 2 minus x. F of 2 minus x, so we replace back 2 minus x. X here as 2 minus x. So 2 minus of 2 minus x. So what do we have? We have 2 plus 2 minus 2 plus x. So the answer is equal to x. Okay, and for the second one, find an expression for g squared x is the same as question A. So g of gx. So what is g? G equal to 3 over x plus 1. So we do the same for this one. We replace the x here both on the left side and right side as 3 over x plus 1. So what do we get? We have 3 over x plus 1 plus 1. So how to simplify this expression? We have fraction inside of fraction. So first we simplify the bottom one first to get into single fraction. So find the common denominator for both of these. So this is actually 1 over 1, right? So to find the common denominator, 3x plus 1 plus 1 over 1, we find it cross the product. So the bottom one will be x plus 1. The top one, it will be 1 multiplied by 3 and x plus 1 multiplied by 1. That's why we have 3 plus x plus 1 over x plus 1. Okay, so this is like 3 over 2 over 5. So how do we do this? So it will be the same as 3 over 2 multiplied by 1 over 5, right? Okay, sorry. So let me rephrase it back. Sorry, So it will be like this like over 3 over 1 over 2. So what do we do? So this is a fraction, right? So it's the same as 3 multiplied by 2 over 1. Okay? So this is like 3 divided by 4 plus x over x plus 1. So it will be 3 multiplied with x plus 1 over 3 over 4. So we can write down as this. So 3 multiplied x plus 1 over x plus 4. So the answer will be 3 of x plus 1 divided by x plus 4. Okay, so this is what you've learned in high school. If we have division with a fraction, so we multiply with the reciprocal of the fraction. Okay, another example, 2 over 3 divided by 1 over 5. So what do? We have 2 over 3 multiplied by, so this division, so 1 multiply will be 5 over 1. So remember this thing lah. This is what we have learned in high school. Okay, so we have the g squared x already. So let's continue. Example 4. If fx equal to 2x minus 1 and gx equal to x cubed, find the values of gf3. Okay, so how to find gf3 is gf of 3. So f of 3, what is f of 3? Directly is equal to 2 multiplied by 3 minus 1. So we just have to replace x with 3 lah. So x here also we replace by 3. So we get 5. So g5 is equal to 5 cubed, which is equal to 125. So directly we can replace the input for each of it. So remember to find the input for f first and then use the output as the input for g. So for question B, fg of 3. So g3 first. So g of 3, so we replace 3 as the x as 3. So we had 3 cubed equal to 27. So f of g3 will be f of 27. So replace x as 27. So 2 multiplied by 27 is equal to 54 minus 1 is 53. So it's not the same as gf3. And question C, f squared 3. So it's f of f3. So f3 is equal to what? So we found already f3 is equal to 2 multiplied by 3 minus 1, which is 5. And f5 is equal to 2 multiplied by 5 minus 1. So it will be 9. Easy, right? Okay, so for example 5, given the fx equal to 2x plus 3 and f of gx equal to 10 minus x, 10x minus 9, find gx. So now we have already the composite f of g and the function f. So we want to find gx. So gx is the inner function here. Okay, because it will be the first function that we find, and then after that the f will be the outer function. Okay, so I separate into these two type of function. So what we want to find is the gx. So how to find gx? So f of gx is equal to 10x minus 9, right? So we know that fx equal to 2x plus 3. So if f of g means that we have to replace the x with gx. Both x will have to replace by gx, left side and the right side. So f of gx is actually equal to 2 of gx plus 3. Okay, so this x replaced by gx. This x also we need to replace by gx. Okay, so now we have 2gx plus 3 on the left side. We have equal to 10x minus 9 on the right side. So to find gx, we just have to let gx as the subject. So bring everything except for gx to the right side. So we will have 2gx equal to 10x minus 12 and gx equal to 5x minus 6. Okay, so for this question, what we want to find is the inner function. Okay, let's do the next example. So we have covered the third learning outcome, which is to find a function, one of the function, if we given the composite and the other function. Example 6, given that gx equal to 2x plus 3 and f of gx equal to 10x minus 9. Find fx. So now what we want to find is the outer function. Okay, so this is the same question as is previous. So how to find if we have the inner function but we want to find the outer function? So here, given that f of g equal to 10x minus 9. So we know the gx already, means that f of 2x plus 3 equal to 10x minus 9. Okay, here what we need to do is to replace this as one variable only. Let's say we let u equal to 2x plus 3. So this x we have to replace it as u, because the left side is in term of u, means that the right side also needs to be in term of u. So to let x in term of u, so we have to let x as the subject here. So what we have is x actually equal to u minus 3 over 2. So if we have replaced the left side as u, it will be f of u, and the right side also need to be replaced as u, means that it's equal to 10 of u minus 3 over 2 minus 9, right? Okay, so now we just have to simplify the right side. So we have 10 divided by 2 is equal to 5. So 5u minus 15 minus 9. So we have 5u minus 24. Okay, so replace back because we want to find fx, not fu. So fx is equal to 5x minus 24. So the example 5 is when we want to find the inner function. But for example 6 is when we want to find the outer function. So please remember these two methods. Okay, let's do example 7. So if f of gx equal to 4x squared minus 2x plus 1 and gx equal to 2x plus 1, find g of fx. Subsequently, find the values of x that satisfy f of gx equal to g of fx. Okay, so the first question is to find g of fx. Okay, so g of fx, now we have g but we don't have fx, so we need to find fx first. So what is our fx? So it's given that f of g is equal to 4x squared minus 2x plus 1. and we know already g means that we want to find f, which is the outer function. Okay, so f of gx, which is f of 2x plus 1 equal to 4x squared minus 2x plus 1. So we need, if it's an outer function we want to find, we have to use let u. So let u equal to 2x plus 1. So x equal to u minus 1 over 2. So we replace both left and right hand side with u. So on the left side will be f of u, and the right side will be f of 4 of x replaced by u minus 1 over 2 squared minus 2 of u minus 1 over 2 plus 1. So now simplify everything. Here is equal to 2. So we have 2u squared. 2u squared. Why we have 4 over 4? Sorry. Not divide, sorry. Here because we haven't square, but these two need to be square. So it will be, it's a 4. So 4 over 4 will be cancelled out already. Sorry for the mistakes. And then this u minus 1 square, we can expand it. It will be u squared minus 2u plus 1. And then minus u minus 1 will be minus u plus 1. And then plus 1. So we have u squared minus 2u minus u plus 1 is plus 2. So this u squared minus 3u plus 3. So to find fx, we have to replace back the u by x. So it will be fx equal to x squared minus 3x plus 3. Okay, that is the first question. Subsequently, they asked to find, we haven't finished the first part of the question, which is we need to find g fx. So g of fx. The next question is g of fx. So we found already, we have already g from the question, and we found already f from the previous working. So we have the fx as x squared minus 3x plus 3. So what is g? G is 2x plus 1. So if we replace the x by x squared minus 3x plus 3, it will be 2 of x squared minus 3x plus 3 plus 1. So simplify everything. We have 2x squared minus 6x plus 6 plus 1. It will be 2x squared minus 6x plus 7. Okay, so we have found out the first equation, the first composite function gf. So the next question, subsequently find the value of x such that f of g is equal to g of f. So what is f of g? Is given in the question. F of g is equal to 4x squared minus 2x plus 1, and we equate with gf because that's what they want us to find when g equal to gf. So gf we found out already in the first part of the question, which is equal to 2x squared minus 6x plus 7. So now we just have to simplify and factorize to get the x, because this is a quadratic equation. So just for the quadratic equation, we have to make sure the right side equal to 0. So I bring everything to the left side. So we have 4x minus 2x equal to 2x squared. Negative 2x plus 6x will be 4x. Plus 1 minus 7 will be minus 6. So simplify, we get x squared plus 2x minus 3 equal to 0. So factorize this equation, quadratic equation. So we have x minus 3, x plus 3x minus 1. So we have x equal to negative 3 and x equal to 1. So this is the results for when fgx equal to g of fx. Okay, that's all for this lecture. So for this lecture, we have only 3 things we need to know. First, to draw the composite, to find the composite, to find f of g or g of f, and the third one to find outer or inner function if we have the composite already. Okay, that's all. Thank you.